Very good morning, children. Today we are going to start our new topic, that is chemical equilibrium. Okay. So before we start this topic, chemical equilibrium, I want to introduce you some terminologies related to the chemical equilibrium. Okay. So generally, in chemistry we have chemical reactions. Okay. The study of the chemical reactions with the different aspects, okay, based upon the different aspects it can be done. The study of chemical reactions can be done with respect to different aspects, and the most important is the study of chemical reactions or the time taken for the completion of the reaction. See, you can study till now, up to in 7th, 8th, 9th and 10th classes, you might have studied about the chemical reaction different types based upon the physical state and chemical states and reversible, irreversible. But the most important aspect of the chemical reaction is what? When it is going to finish, when all the reactants are going to form as the product. So what is the criteria we are taking here based upon the time? Okay, so now the chemical reactions based upon the time, okay, they are being calculated, and this, so how much of reactant is going to form into product. So what is happening here, after some time the reactants are going to transform as products. So there will be decrease in the concentration of the reactants and there will be increase in the concentration of the products. Is it or not? Suppose if you react to 1 kg A plus B gives rise to C. See here what happens when time proceeds, the concentration symbol is this. The concentration of A decreases and the concentration of C increases as the time proceeds. So based upon the time, the chemical reactions can be classified as 3 types. Okay, so the study of these all, how the concentration is going on and everything, that we call it as kinetics, chemical kinetics. Okay, the study of this is called as the kinetics, that is the chemical kinetics, the branch of chemistry which deals with these all aspects, how much of reactant is being converted to the product, that is called as the chemical kinetics. And under that, equilibrium concept we will be studying. Okay, so the kinetics of the reversible reactions, okay, is studied under equilibrium concept. Okay, so this is all about the introduction part of the equilibrium. Kinetics means what? How much of reactant is being in what time it is going to form as products. Means the decrease, there will be decrease in the concentration of the reactants and there will be increase in the concentration of the products. So based upon the time, the reactions are again classified as 3. One as instantaneous reactions. Okay, instantaneous means with a short time period. Okay, immediately, effectively they will be doing burning of the paper. It's an instantaneous reaction. Explosion, it is an instantaneous reaction. And moderate reactions. And moderate reactions means what? Which takes some hours of time. Okay, not more than 24 hours of time. Okay, so those are called moderate reactions. And slow reactions, which takes so much of time consuming. See, photosynthesis, we can take it as a moderate reaction. Digestion of food is a moderate reaction, but whereas growing of human body, it is a slow reaction. Is it or not? Growing of a plant is a slow reaction. So these are all time consuming process. Okay, based upon the time, the reactions, and the branch of chemistry which deals with the kinetics of the reactions is nothing but chemical kinetics. Okay, and that particular chemical kinetics we study for reversible reactions only. And majorly equilibrium kinetics, that is related to the equilibrium concept. So this is all about the introduction part of chemical equilibrium. So what is a chemical equilibrium? So generally, what is a chemical equilibrium? First, that will be our discussion now. So before going to that, the study of chemical reactions can be done with respect to two different aspects. The most important aspect of the study of chemical reactions are time taken for the completion of the reaction and the favorable conditions required for the respective reactions. The branch of chemistry which deals with the time and the favorable conditions of a chemical reaction is called as chemical kinetics, and the kinetics of the reversible is studied as chemical equilibrium. Okay, so in chemical kinetics what we will be studying? We will be studying about the time taken and favorable conditions. What are the favorable conditions for the reaction? Okay, so these points will be covered under chemical kinetics, and the branch of chemistry, okay, which deals with the time taken for the reactants to change us to the products and what are the favorable conditions for that comes under chemical kinetics. Chemical kinetics, and the kinetics of reversible reaction is studied as chemical equilibrium. The kinetics of reversible reactions is studied as chemical equilibrium. So now one thing is very clear. What is that? Equilibrium is only for reversible reactions. Okay, it is only for reversible reaction. And one more logic is what? As the time proceeds, there will be decrease in the concentration of the reactants and there will be increase in the concentration of the products. And the concentration symbol is what? This. Okay, when you write anything like this in chemistry, that is represented as concentration. And based upon the time, the reactants, chemical reactions, in chemical kinetics, the reactions are classified as instantaneous reactions, moderate reactions and slow reactions. So now I will be giving you the detailed notes of this discussion. So now we will be having the detailed notes of these things. So what is the first point is the study of chemical reactions can be done with respect to different aspects. With respect to different aspects. The most important aspect is the most important aspects of the study of chemical reactions are the time taken for the formation of for the completion of the reaction and the favorable conditions required for the respective reactions. The branch of chemistry which deals with the above aspects, which deals with the above aspects is called chemical kinetics. Okay, chemical kinetics. And what is kinetics means? This is the definition. The study of chemical reactions can be done with respect to different aspects. Okay, based upon the physical, chemical, all that. But out of all those, the most important is what? How the reactants are changing to products. What is the time taken for the completion of the reaction, and what are the favorable conditions for that to proceed the reaction? That we study under the what? Chemical kinetics. Okay, and the kinetics of reversible reaction is studied by the chemical equilibrium. The kinetics of reversible reaction. A reversible reaction is studied as chemical equilibrium. Okay. Next, on the basis of time taken, okay, on the basis of time taken for the completion of the reaction, for the completion of the reaction, okay, for the completion of the reaction, chemical reactions are classified as chemical reactions are classified as one, instantaneous reactions. Okay, instantaneous reaction, and the number 2 is slow reactions and moderate reactions. Okay, moderate reactions. Okay, please make a note of all this. Now we will be having the next instantaneous reactions. So what are the instantaneous reactions? The reactions which take within a fraction of seconds. Okay, the reactions which take in the form of fraction of seconds, that is called as instantaneous reactions. Reaction of active metals is an instantaneous reaction. Okay, and all the acid base, okay, all the acid base reactions, that is neutralization reactions. Most of the neutralization reactions are instantaneous reactions only. And what are the slow reactions? So what are the slow reactions? What does it mean? Okay, the slow reactions are what? Which takes some days, some months. Those are called as slow reactions. Example one is what? Formation of lead, rusting of iron. These are all examples of slow reactions. All the biochemical reactions are slow reactions only. Why? They take decomposition. For the biological decomposition, it takes time. So those are slow reactions. And what are moderate reactions? Which happens between instantaneous and slow reactions. Okay, in between the time, that is, they are not super fast and they are not dead slow. They will happen in hours only. Those are called as moderate reactions. What are the examples? Cooking of food, digestion of the food, photosynthesis. All these are the examples of moderate reactions. Okay. So most of our chemical reactions are classified into these three categories only. You can have a notes of all these points. Hope you have noted. The next step, the definitions we will go. Instantaneous reactions. What are instantaneous reactions? Which occur in fraction of time. Okay? The reactions which occur in the fraction of time, those are called as the instantaneous reactions. Okay, the reactions which are completed within a fraction of a second. The reactions which are completed in fraction of second. Which are completed in fraction of second. Fraction of a second are called instantaneous reactions. Okay, are called as instantaneous reactions. Okay, so most of the examples, most of the precipitation reactions, most of the precipitation reactions are instantaneous reactions only. Okay, most of the precipitation reactions are that. And next, reactions of active metals. Reactions of active metals. Reactions of active metals. And some biological reactions involving muscle contractions and the transmission of nerve impulses. These are also that, and neutralization reaction. So acid base. Okay, acid base neutralization reactions. Acid base neutralization reaction between strong acid and strong base. Between strong acid and strong base. So these are the best examples. Okay. Next, when you consider the exposure of the sodium to the air, phosphorus burning, all these are instantaneous explosions. All these are what? Instantaneous reactions. Okay, and some biological. Okay, some biological reaction involving muscle. Okay, some biological one involving muscle contractions. Muscle contractions. Okay, and the transmission of nerve impulses. Is it or not? So that, okay, transmission of the nerve impulses. Okay, so these are the examples of what are called instantaneous reactions. You can make a note clearly. Instantaneous means which happens in a fraction of a second. Okay, burning of phosphorus, exposure of sodium, silver nitrate formation, all these are examples. LPG blast, explosives, all these are the examples of what instantaneous reactions only. Next, what are slow reactions? Means the reactions which take days, months, or some years for completion of the reaction are called as slow reactions. Okay, examples: rusting of iron. Rusting of iron will take days. Okay, so that is rusting of iron. Corrosion of metals, we can call it, we can consider corrosion of metals also. Corrosion of metals. Corrosion of metals is also an example of slow reaction only. Okay, and decomposition of biodegradable organic matter. Okay, decomposition of biodegradable organic matter, biogas formation, all these are the examples of slow reaction. They take so much of time. Alcohol for preparation, fermentation process, all these are the examples of slow reactions only. And the next we have moderate reactions. Means what? Which take time to finish within hours only, not more than a day. Okay, those are called as what? Moderate reactions. Okay. Okay. The reactions which take complete within minutes or hours are called as moderate reactions. Okay, so moderate reactions, most of this photosynthesis is a moderate reaction only. Digestion of food is a moderate reaction. Cooking of food is a moderate reaction. So these are all the introduction for chemical kinetics. The next what we have for the discussion is rate of a reaction. Okay, what is meant by rate? So you might have studied, if anything is defined as rate, means what is the exact definition for that rate? Rate means what? That we will see. Now, you please make a note of these points. See, now we will be discussing about the major topic, that is rate of a reaction. Okay, rate of a reaction, which is denoted by small r. So what we are saying, during a chemical reaction, what happens? There will be decreasing concentration of reactants and increasing concentration of products as time proceeds. Is it or not? As time proceeds, what happens? There will be decrease in the concentration of the reactants and there will be increase in the concentration of the reactants. That is nothing but the change in concentration of reactants or products with respect to time is called as rate of a reaction. Okay, rate of a reaction is nothing but change in rate of a reaction means what? It is nothing but the change in concentration of the reactants or products with respect to the time. Rate means with respect to time. Denominator consists of time. And there are two types: decrease in concentration of the reactant and increase in concentration of the reactant. So what I can write now? The rate of a reaction will be different again. Suppose if you take A plus B gives rise to C, the rate of reaction with respect to A is different, the rate of reaction with respect to B is also different. Why it is like that? With respect to A, the rate of reaction will be change of A only. With respect to B, change of B only. See what we are saying here. I will write here, rate of reaction with respect to A is nothing but change in concentration of A. Is it or not? Change in concentration of A by time. It is decreasing. Why it is in reactant side? So minus. At the same time, rate of reaction with respect to B is, again it is also reactant side only. So change in concentration of B by time minus. Why? It is reactant side only. And next what? Products. What is the product? With respect to product we have to write. So rate of reaction with respect to C, change in concentration of C by T. It is positive. It is positive. Plus sign will be there. So for positive, no need to write plus. Why? Increase in concentration of the products. Decrease in concentration. Minus means decrease. Okay. So that is the thing we have. Okay. Rate of reaction. Concentration of the products and the concentration of the reactants are shown like this. You can note down this point. Rate of a reaction. How you will be defining the rate of a reaction? So what is going to happen? During a chemical reaction, the reactants gradually disappear and the products gradually appear. Is it or not? During a chemical reaction, what is going to happen? The reactants will disappear and gradually the products will generate it. Is it or not? reactants disappear, okay, and products generated. So during a reaction, this is the common phenomenon. Reactants will be disappearing and the products will be generated. So what is the rate of a reaction? The change in concentration that we are seeing with respect to reactants and products with respect to the time. So this is rate of reaction. Okay, rate of reaction is change in concentration. So I can write like this: change in concentration of reactants or products by time is nothing but rate of reaction. Okay, what is rate of reaction means this. We will write the definition for that. The change in concentration of products are, you can note down, the change in concentration of reactants or products with respect to time is called as rate of reaction. Okay, so time again, initial and final. Yes, take it, delta T, no problem. Initial and final, delta T, increase. So initial and final will be there now. Yes, change is delta T, you can take it, no problem. Delta means change. This symbol is concentration. Why minus? If minus is given means what? It is understood that it is a reactant. If plus means it is understood that it is a product. That it should come to your mind. And the most important thing is what? The rate of reaction is depending upon stoichiometric equation. That is, it should be balanced equation first. Then only you can write the rate of reaction. Otherwise, what will happen? Again, there will be changes. Okay. What I can conclude? The rate of reaction with respect to a particular reactant or product depends upon the stoichiometric coefficients of that substance in a balanced chemical equation. So this point is most important point. You have to note down. Okay, please note down this point. The rate of a reaction with respect to a particular reactant or a product, with respect to a particular reactant or a product, depends upon the stoichiometric coefficient of that substance, in a balanced chemical equation. The rate of reaction with respect to products is always represented by positive sign. Which indicates an increase in concentration of products with time. Next point is what? The rate of reaction with respect to reactants. The rate of reaction with respect to reactants is always represented by negative sign, which indicates which indicates decrease in the concentration of reactants with respect to time. Okay. Now concentration. What are the units we will see? Concentration means what? Either it may be molarity or molarity, whatever it may. So rate of reaction is mole liter inverse second inverse. Okay. Mole liter inverse second inverse with respect to time. Again, it depends upon the order of the reaction. Either it is first order, second order, or third order. Again, these units will change. Okay. So in general, the rate of reaction units concentration is expressed in mole liter inverse with respect to time. So mole liter inverse second inverse. Only up to this class. Afterwards, again the rate of reaction units will change. Okay. There will be changes. Chemical kinetics will come again. First order, second order, third order reactions will differ again. Okay. Accordingly, we will be seeing that. You will be getting in the next video. So this is all about the equilibrium introduction part. Okay. How to write the rate of reaction and everything you can see in the next video. If you have any doubts or anything, you can call me or send me on WhatsApp group. Okay. So rate of reaction, how to write the rate of reactions we will see in the next video. And there is one theory, already you have studied this kinetic theory. Okay, kinetic molecular theory of states of matter, but particularly you have to focus on kinetic molecular theory of gases only. Okay, so why means totally the equilibrium and the chemical kinetics we will be studying in for gases product only. That in the next video we will be having the discussion regarding how to write rate of reaction. Okay, how to write the rate of reactions we will be seeing in the next video. So what is the graph means? What happens? Decreases. Okay, with respect to reactants and time. The rate of reaction with respect to reactants and time, it decreases as the time proceeds. And with respect to products and time, it increases as the time. The concentration of the reactant versus time, concentration of the product versus time. This is the graphical representations. Anyhow, we will be discussing all this in the coming videos. So in this video, I have covered you what is chemical kinetics. Okay, and next, what is the definition of rate of reaction.